This is alcohol esters carboxylic acid tutorial presented by the USHRZB with reference International US A-Level Chemistry by Laurie Ryan and Roger Norris. So we start with the learning outcome of alcohol carboxylic acid tutorial. So learning outcome, we have recalled the chemistry of alcohol such as ethanol in combustion substitution to give halogenol alkane, reaction in sodium, oxidation of carbonyl compound. We have classified hydro Z compounds in primary, secondary, and tertiary alcohol. We also suggest the characteristic distinguishing reactions, e.g. mild oxidation. We have described the acids, base, and hydrolysis of esters. We have said the major commercial uses of esters, e.g. solvent, perfume, flavoring. Describe the formation of carboxylic acid from alcohol, aldehydes, and nitrite. We have described the reaction of carboxylic acid in formation of salts by the use of metal reactive reagent, alkali, carbonates, alkyl esters, reaction of alcohol with alcohol, and we have alcohols by use of lithium aluminum tetrahydride. So we can start. So we first start with alcohol. So the point to found alcohol is that it's a homologous series containing a functional group which is OH and having the general formula of CN H2N plus 1 OH. That's the homologous series of alcohols. So example, we have propan 1-or. We need to know how to distinguish between each of the primary, secondary, and tertiary alcohol. Primary alcohol, you need to know that the OH group is going to be bounded to directly to a CH2 bond, to a CH2 group. The OH functional group is going to be bounded to a CH2 group for primary alcohol. For secondary alcohol, the OH group is going to be bounded to the CH group, and for the tertiary alcohol, we have the OH bounded to a C carbon atom. So there is no H attached. Here you instead have all alkyl groups. Here you have only one alkyl group for secondary alcohol, and for primary you have no alkyl group attached to it. So now the next point to put in mind is propan 1-or. This one is a primary alcohol, secondary alcohol, and this is tertiary alcohol. Now let's go to the reaction of alcohols. So you need to know that all hydrocarbons are going to react to produce the same thing. So we have ethanol is going to react with oxygen to produce carbon dioxide and water. You need to know that combustion mostly produce carbon dioxide and water and also release heat. So that's the same thing with ethanol plus oxygen to produce carbon dioxide and water. And now that is why this ethanol is used in a country like Brazil. Ethanol is used in a country like Brazil to use is used to fuel, is used in fuel. So you actually have fuels being ethanol in a country like Brazil, and people were taking those fuel and drinking. So this is why the government of Brazil decided to add up this alcohol with some gasoline, with some other fuel to be like petrol, in order to make the people not drink again this ethanol much. So now the fuel called gasohol is actually ethanol plus petrol. So we have the next one. We have the next reaction is going to be substitution of to form halogenoalkane. So you need to know that when one alcohol react with a hydrogen halide, like hydrogen chloride, hydrogen bromide, hydrogen fluoride, all of them, they can produce this reaction is going to produce halogenoalkanes. So now let's visualize how. So ethanol plus hydrochloric acid is going to produce chloroethane. So that's the reaction. So now sodium chloride, like in the case of sodium chloride plus all that. So now let's visualize the reaction. So in this reaction, actually the molecule is not actually hydrogen chloride. What is given for this reaction, sodium chloride, the ethanol molecule is added plus sodium chloride and sulfuric acid, and this hydrogen chloride is going to be produced in situ. So hydrogen chloride is going to be produced in situ. So we have dry chlorine hydrogen chloride gas can be made in situ in the reaction vessels that we see there, and concentrated sulfuric acid. So when you have concentrated sulfuric acid and sodium chloride, is going to form this, and it's going to be produced in situ. When it's produced in situ, now it can form chloroethane from ethanol. So this is going to occur in a reflux, and now this chloroethane can now evaporate and now be collected in this other tank here when it condenses. So now let's visualize other parts. We have at this point here we have the test for the OH. You need to know that the OH functional group can be tested. You can test the OH functional group with sulfur dichloride oxide, or you can test it with phosphorus pentachloride. So sulfur dichloride oxide, in this reaction you need to know that in both of these reactions there's always going to be fumes of hydrochloric acid. Wide fumes of hydrochloric acid is going to be produced. So here in this reaction you have a haloalkane. You are going to produce haloalkane called chloroethane. You are going to produce hydrochloric acid and going to produce sulfur dioxide. But in this reaction at room temperature, so at room temperature you have phosphorus pentachloride reacting to produce C5A chloroethane plus hydrochloric acid plus POCl3. So now if you react instead with this one, you are going to form iodoethane, and you are not going to produce hydrogen iodide, but you are instead going to produce H3PO3. So this is what some phosphorus acid that you are going to produce. So now let's visualize now the reaction with sodium metal. So we need to know that when it reacts with sodium metal, it's going to produce sodium ethoxide. So ethanol plus sodium is going to produce sodium ethoxide, which first formula is like that, and you have hydrogen. The point you need to know that is that all alcohol are going to react with sodium to produce sodium alkoxide plus hydrogen. So you are going to see fumes of hydrogen that is going to come out from the water bubbles. So you are going to see some water bubbles as in this diagram. So now let's go to CS esterification. So before you see esterification, you need to have some certain properties of an ester. An ester has a fruitful, pleasant smell. That is why you see this woman here having perfume in her hand. So and this is due to esters, because esters are found in perfumes. So an esters are found when you have carboxylic acid and alcohol reacting together to produce esters and water only. So when you have a carboxylic acid and alcohol, both of them react together, they are going to produce ester and water. So now you use a catalyst for this reaction to occur. So now let's visualize here. You have ethanol, you have ethanoic acid, you have ethyl ethanoate, and you have water. So ethanoic acid, when you bind the two, in cases of the catalyst here is going to be concentrated sulfuric acid, you're going to produce ethyl ethanoate and you're going to produce water. So it can also occur with ethyl propanoate. So that's because the first, so you see, you need to know that what will be the name of the ester. That is, you name this ester with respect to this one. This one here is an ethyl group, and this one here is a methyl group. So this one here, you see that there are two carbon atoms. You name the ester from this. The first part of this ester come from this part here, and the second part comes from this main chain. So since this one has two carbon atoms, it's already going to be called ethanoate, and this one is an ethyl group, so that's why you have ethyl ethanoate. So now let's see this case. In this case, the main molecule is 1, 2, 3 carbon. That's why it's already called propanoate. And now the side molecule which is found down here is ethyl, so that's why it's ethyl propanoate. That's how we name it. But now this reaction down, the more you increase the chain of the propanoic acid or the ethanol, the less the reaction. So that's why the greater the saturation of a reaction, the lesser the reaction rate. The next thing we have dehydration. Dehydration refers to the removal of water from alcohol in presence of a catalyst. Example of that catalyst is going to be aluminium oxide. So ethanol in presence of aluminium oxide is going to produce ethane and water. So this is the reaction medium. So you have ethanol and soaking ceramic wool soaking in ethanol, and this ceramic wool is made up of this. You heat it. When you heat it, it's going to pass into water and then it's going to come out as ethane gas. So now on the next one, we have oxidation of alcohol. We need to know that oxidation of alcohol depends on which type of alcohol we have. If you have a primary alcohol, the oxidation is going to differ from that of secondary alcohol, from that of tertiary alcohol. So now let's visualize. In case of a primary alcohol, the first oxidation, so you need to know that the primary alcohol are going to have two main types of oxidation. We have a partial oxidation, we have a full oxidation. So the partial oxidation of the primary alcohol is going to produce the aldehyde. In this case of alcohol of ethanol, is going to produce ethanol, and the full oxidation of this ethanol of the alcohol is going to produce a carboxylic acid. In the case of ethanol, it's going to produce ethanoic acid. So we first have a partial oxidation of this ethanol to produce ethanol, and then the full oxidation of ethanol to produce ethanoic acid associated. So these are the formulae. So now this is how we make to distinguish a tertiary alcohol. So in order to distinguish with tertiary alcohol, you need to know that primary alcohol can produce aldehyde and carboxylic acid. Secondary alcohol are going to produce ketones. Secondary alcohol oxidation are going to produce ketones, while tertiary alcohol oxidation produce nothing. The reason is because oxidation is in order for you to have oxidation, you are required to have a hydrogen atom at this position here on the carbon atom, which is bonded to the OH group. You are required to have a hydrogen atom on the carbon atom bonded to OH group. You need to know that since there are two hydrogen atoms in case of primary alcohol, there are two oxidation that occur. That is a partial and a full oxidation that occur for the case of primary alcohol. Now, since there is only one hydrogen in case of secondary alcohol, which is bounded to the OH, there is only one oxidation that is going to occur in case that is going to be used in the formation of ketones. And lastly, for tertiary alcohol, since there is no hydrogen bounded to the hydroxide of which is directly bound to carbon, we see that it's not going to be oxidized. The next one, this is how you can make to distinguish. In this case, you see that when you place this molecule, when you oxidize it, oxidizing in presence of when you warm it in presence of silver ion, what you realize that when you oxidize in presence of silver ion, you see that silver molecules are going to be formed here. So you see that these are going to react. So before warming, label the alcohols. So now this is potassium dichromate. So potassium dichromate have been used in case of primary, secondary, and tertiary. Potassium can be used in primary, secondary, and tertiary alcohols. We see that both primary and secondary has been oxidized by potassium dichromate, and that is why there is green chromium that has been formed in both of them. While in tertiary, they have not been oxidized by potassium dichromate, and that is why nothing is formed here. So now let's visualize carboxylic acids. This is a formation of carboxylic acid. You have reaction of carboxylic acid, formation of carboxylic acid. You can form carboxylic acid from the ethanol and from nitrites. So in case of propanonitrite, you can just react it plus water. So when you hydrolyze a nitrite, you form a carboxylic acid. Just note that. So you can hydrolyze it. You do a acid hydrolysis, that is, you add an acid and you add water. Both of them are going to produce this molecule. You can also do an alkaline hydrolysis, but here it's going to be ammonia that's going to be formed. So now the next point is going to be reaction as acid. So how do you react as acid? You need to know that ethanoic acid is actually an acid basic weak acid. So you can react now with sodium hydroxide, produce sodium ethanoate. So produce sodium ethanoate plus water. You can react with magnesium, produce magnesium ethanoate plus hydrogen. So you can react with magnesium, produce magnesium ethanoate plus hydrogen. You can react with sodium to produce sodium ethanoate plus hydrogen. You need to know that anytime a metal react with a molecule that contains OH, they always release hydrogen. That's why you're going to have bubbles seen in solution. The next one is reduction of carboxylic acid. So when you reduce carboxylic acid, you are going to form alcohol. Another reduction is going to take place with the use of lithium aluminum tetrahydride. And the point to note is that the lithium aluminum tetrahydride should be inside dry ether and at room temperature. And now you need to know that dry ether is used because lithium aluminum tetrahydride is reacting violently in water. So we don't use lithium aluminum tetrahydride inside water. You instead use lithium aluminum tetrahydride inside dry ether. So this reaction occurs inside dry ether to produce an alcohol and water. So from here we say thanks for your kind, and this is the end of the tutorial of alcohol, esters, and carboxylic acid. I will say thanks for your kind attention. Please don't forget to like and subscribe for the channel. Thank you.